and normal components, and this is the third way, which is using r theta or polar coordinates. So when do we use polar coordinates? Well, whenever you have motion described by r, the radius, and theta, I'll show what that means. So this is the curve along which let's say the particle moves, and we decide an origin O. So the particle is here initially, and it moves upwards. Okay, eventually it is at this position, and this position is described by two variables. One of them is r, is basically the distance from O to the position where the particle is currently, and by an angle theta. And a convention is clockwise is negative and counterclockwise, the way I've shown it here, is positive. Okay, so just like there is ut, un, and ijk, you need unit vectors to describe the position. So unit vectors for this particular coordinate frame is ur, u theta, and let me just draw it with a different color. So this is ur. Okay, it points outwards from the origin towards the position of the particle, and u theta is going to be right angles to ur. Okay, and it's pointing the direction which the particle is moving. Now, one thing, this may not be clear. Let me just redraw this curve here. What I want you to note is that we superpose this right here. Okay, the point I'm trying to make is u theta is not in the tangential direction. Okay, do not show it along the tangential direction. Now there are cases where u theta is along ut. Okay, like when things are going in a circle, yes, ut is u theta, but in general ut is not u theta. So I'm going to write this down. U theta need not be along the tangent to the curve, or u theta is not necessarily equal to ut. Okay, so given that, we can now try to write position, velocity, acceleration, same things we wrote earlier. Let's look at the position first. The position is r, and r is simply the magnitude of r times the unit vector in the r direction. Velocity. To find the velocity, we need to take the vector r, differentiate with respect to time, and the derivation takes a little bit of steps. I'm going to skip that. You can refer to the book for that. The velocity is r dot. It has two components. There is a component in the r direction, that's r dot times ur, plus r times theta dot along u theta. Another way of writing this is vr ur, where vr represents the r component, and v theta represents the theta component. And then finally, acceleration, A is the rate of change of velocity. That expression is, again, you can do this derivation, it's in the book. It's r double dot minus r theta dot square along ur plus 2 r dot theta dot plus r times theta double dot u theta. A shortened way of writing this is ar ur plus a theta u theta. Okay, so given this, let's see how to apply this and solve problems.
Say that with the position, that it's the magnitude times the unit vector.
Magnitude times unit vector, yes. Okay. A particle is moving along a circular path having a radius of 4 inch such that its position as a function of time is given by theta equals cosine 2t. If theta is in radians and t is in seconds, determine the magnitude of the acceleration of the particle when theta is 30 degrees. Okay, so let's see what's going on. So theta is cosine 2t. Okay. So at t equals 0, this is going to be cosine of 0, which is 1. Okay, that's 1 radians. So assuming this is 0, that's 90 degrees. 90 degrees pi by 2, which is 3.4. So what's one radians in degrees? 57 degrees, right? So it's about here. So this is where the particle is at t equals 0. Okay, and then it's moving along a circle such that theta varies as a function of time this way. Okay, you're told to find the magnitude of the acceleration when theta is 30 degrees. I think I did a mistake. So it's not going counterclockwise, it's going clockwise, because when t increases, cosine will actually decrease. So it's actually going to go this way. Right? So for example, if you see t equals 1, we have cosine of 2. Let me put, just to make my life easy, I'm going to put t equals pi divided by 2. So if you put pi by 2, you get cosine of pi, which is, what's cosine of pi? -1. So it's going negative. So that means it's moving this way and not counterclockwise like I had shown it earlier. Okay, so we got to find the acceleration. Okay, well, you do not need to draw that figure to find the acceleration, just plug and chuck, but I just wanted to show you what it really means physically for the particle to move in a circle the way it's described by that equation. Okay, so acceleration, as we know, is r double dot minus r theta dot square ur plus r theta double dot plus 2 r dot theta dot u theta. Okay, let's try to find each of those terms. So r is 4, right? That's the radius of the circle, 4. Okay, what's r dot? It's 0 because the radius is not changing with time. So r dot is 0, r double dot is 0. Theta is cosine of 2t. So theta dot is going to be minus sine 2t. That's the derivative of cosine, and then I need to take the derivative of the thing inside the bracket. So it's going to be derivative of 2t with respect to time, which is going to be 2. And then theta double dot is going to be, again I need to take the derivative of sine 2t, that's cosine 2t. There is a 2 coming from the derivative of 2t, which is 2, and then I need to carry over the 2, which I already found earlier. So those are the derivatives. Okay, so now I can plug them in the equation. 0 minus r, which is 4, theta dot. Okay, before I can put theta dot there, I need to find a value for theta dot. So how can I find a value for theta dot? I can only find that if I know t. Right, so I need to first solve for t. So what I'll do is, I know that I need to find what happens at theta equals 30 degrees. So I'm going to put theta equals 30. Now I cannot put 30, I need to put the answer in radians because theta is in radians. So theta in radians is pi divided by 6, that's 30 degrees, equals cosine 2t. And then I can solve for t, which is half of cosine inverse of pi divided by 6. So that comes out to be 0.51 seconds. Okay, so now with this information I can now go back and plug it in here and solve for theta dot. So theta dot, after plugging in the value for t, comes out to be minus 1.7039, and theta double dot is minus 2.094. Okay, so with that I can now solve for acceleration. Acceleration is r double dot, which is 0, r which is 4, theta dot is minus 1.7039 square ur plus r is 4, theta double dot is minus 2.094 plus 2 times r dot is 0, so it doesn't matter what is there for theta dot, u theta. So this is 0, 0, comes out to be negative 11.161 ur minus 8.38 u theta. Okay, so that's my acceleration. However, you're asked to find the magnitude of the acceleration. So you want to find a scalar. The magnitude of acceleration is square root of the r component, well, square root of the sum of squares of the r component and the theta components. That comes out to be 14 0.3 units are inch per second square. Any questions? Yeah. 0.51 second. I just put so pi by 6 cosine inverse of pi by 6. You find that using your calculator, and then you just do half of that. Did you check it out? So your calculator would have cosine inverse, right? So how it's pi by 6? Is that the question? Are you asking what is pi by 6? Pi by 6 is 30 degrees. And theta is given in radians, not in degrees. So I have to convert to radians. Yeah.
Can you explain the direction how it's going down?
Oh yeah. So first of all, at t equals 0, I put this value, find what theta is. That comes out to be 57 degrees. Okay, then the question is what happens after t going forward? If you put if as t increases, cosine decreases, so it's going to be less than 1. And when it's less than 1, it's going to be in this direction. The angle, you can just put some value for t, put 0.5 or 0.7, and then find what theta is. So you just do it for multiple points, and that's how you figure out the direction. I just did it for 1 point. Okay, any other questions? Okay, let's see if we can solve this problem based on what we did just now. So peg P is driven by a fork link OA along the path described by r equals e raised to theta, where r is in meters, theta is pi by 4 radians. You're given the angular speed, angular acceleration. Determine the radial and transverse component of the peg's acceleration at this instant. So what I would say is, instead of giving this, compute the magnitude of acceleration. Compute the magnitude of the acceleration. Okay, so try to find a equals ar square plus a theta square, right, where a equals ar ur plus a theta u theta. So from the information, find magnitude, not the radial and transverse component, and then pole that answer. Yes, pole the magnitude.
Yes.
Okay, still 12 people not responding.
Okay, so I should put in this one.
It will stop.
And this was UR. 8 is AR.
Okay, so let's try to get, well, we need r dot, r double dot, similarly for theta. So let me write theta. So theta is pi divided by 4. Theta dot is, it's already given, it's 2, and theta double dot is also given as 4. Okay, so to find r dot, and this is where many people do a mistake, is this is e times theta, right? Derivative of e raised to theta with respect to theta is what you need to do first, and then you need to take the derivative of theta with respect to time. So that's something which people miss out. That's the chain rule. And then when you take the derivative of two terms, e theta and theta dot, it's a product rule. So you keep one term constant, differentiate the second one, and vice versa. So let's keep e theta constant first, differentiate theta dot with respect to time, that's theta double dot. Then we'll keep theta dot constant and take the derivative of e theta with respect to time. So derivative of e theta with respect to time is e raised to theta times theta dot. Okay, so let's get the numeric values for this. R equals e raised to theta. Theta is pi divided by 4. .19. R dot is, well, 2.19 because we found that, times theta dot, which is 2. That's 4.38. And R double dot is 2.19 times theta double dot, which is 4, plus e theta, which is 2.19, and then theta dot times theta dot is theta dot squared, so 2 squared. So this comes out to be times 8, so 17.55. Is that right? Okay, so given that, let's find AR, which is R double dot minus R theta dot squared. R double dot is 17.55 minus R, which is 2.19, times theta dot squared, so that's 2 squared. 17.4 times 2.19, so 8.79. And A theta is R theta double dot plus 2 R dot theta dot. So R is 2.19, theta double dot is 4, plus 2 times R dot is 4.38, and theta dot is 2. So 26.28, right? And then acceleration is, the magnitude is AR square, so 8.79 square plus 26.28 square. So 27.71. I don't quite know the units, I just keep it as it is. Okay, questions? Is that clear? Yeah. Say that again. Yeah. What's that? What's the question? Yes. And then I just plugged it in here. Okay, other question? Okay, so let's grade this. What was round? Say it again. Oh, that's fine. 7-2, that's not a problem. Please clear it. Okay, so that's okay. This is okay. I'm looking at 27. That's I don't know how we got 26. Who got 26.3? It's is that okay? Okay. Okay. Next question. So the car travels along a road which for a distance is defined by this formula. So that's how the curve, the radius is described, where theta is in radians. If it maintains a constant speed, okay, the car maintains constant speed, determine the radial and transverse component of its velocity when theta is pi divided by 3. So let's see what is asked. So V is VR UR plus V theta U theta, but that is R dot UR plus R theta dot U theta. So we're asked to find this quantity and this quantity. So we need to find R dot, and theta dot, right? Okay, let's see what are the knowns. We're given that R is 200 divided by theta. We also given theta is pi divided by 3. So R is no problem. We can figure out R easily. Okay, let's try to find R dot and theta dot. R dot is, so I need to take the derivative of R with respect to time. Okay, so I'll keep 200, that's a constant. I need to take the derivative of 1 divided by theta. So the derivative of 1 divided by theta with respect to time is, first I differentiate 1 divided by theta with respect to theta. So that will be 1 divided by theta square. And then I need to differentiate theta with respect to time. So I would have theta dot. Right, that's the product rule. So that's minus 200 theta dot divided by theta square. Here the issue is I do not know theta dot. I do know what theta is, it's given. Okay, so in this expression r dot is unknown, theta dot is unknown. Okay, just because theta is pi by 3 doesn't mean theta dot is 0. In fact, theta dot cannot be 0 unless, if that is 0, then it's not really moving with uniform speed. Okay, so let's see, I've used all but this piece of information. I've not used the fact that it's moving at constant speed. So let's see what it means to move at a constant speed. So given that V is 35 and that's constant. Okay, so when you say the velocity is constant, it means that you're given the magnitude of the velocity. So we will write the magnitude of V is 35, but we know that the magnitude is simply the r component squared, so r dot square, plus the v theta component, so r theta dot square. So that is given. So what I'm going to try to do is now is sub in the value for r dot and r in that expression. So let's put this right here. So that's minus 200 theta dot divided by theta square into square the whole thing plus r, which is 200 divided by theta. So 200 divided by theta and then the theta dot is an unknown, so square is 35. So I can write 35 equals, well, I know what theta is. It's pi divided by 3. So I'm going to sub that in. Minus 200 theta dot divided by pi by 3 square, and I have to square this whole thing, plus 200 theta dot divided by pi divided by 3 square. Okay, so